Hello, rising fifth graders. This is the second installment of videos designed to give you some of the basics of fractions heading into fifth grade. The first video defined a fraction. A fraction is a point on the number line. How does the symbolism of the fraction indicate to us where that point is on the number line? The purpose of this video is to talk about the so-called improper fraction and how improper fractions can be thought of and rewritten as either whole numbers or mixed numbers. I'm going to give you 4 examples. You're not expected to understand it at this point. I just want to give you sort of a sense of where we're headed. On the top here, we have 4 fractions that are commonly known as improper. An improper fraction is a fraction that is greater than or equal to the whole number 1. Or another way of saying this is, the numerator is greater than or equal to the denominator. With the fraction 5/5, the numerator is equal to the denominator, and 5/5 is equal to the whole number 1. In this case, the numerator is 8, denominator 4. The numerator is greater than the denominator, improper fraction. 8/4 happens to be equal to the whole number 2. These arrows that I've written down here are equal signs. 12/7. 12/7 is not a whole number, but it can be expressed as 1 and 5/7. Now, this number 1 and 5/7 is known as a mixed number because it's a mixture of a whole number and a fraction. But what it really is a sum. 1 and 5/7 is simply the whole number 1 plus 5/7 more. We don't write the plus sign, but we say and when we are naming this mixed number 1 and 5/7. That indicates an addition. So let's understand something, try to understand it without reference to a physical number line. 12/7. Well, you divide the distance between each whole number into 7 equally sized pieces. That's what the denominator tells you to do. And then the numerator tells you which one is it. We're going to count starting from 0, just counting these sevenths. 1/7, 2/7, 3/7, and so on. 12/7 is the 12th seventh past 0. But it's also the 5th seventh past 1. 12/7 and 1 and 5/7 are the exact same point on the number line. They are equal to each other. 31/6. Well, if we created a 6th number line, divided the distance between 0 and 1, 1 and 2, 2 and 3, and so on, into 6 equally sized pieces, and then we simply started counting them, and we went all the way to the 31st sixth. Where is that on the number line? How much is 31/6? Well, the reason we often have a preference for these mixed numbers down here is because we have a better understanding of the quantity. Where is it on the number line? 31/6 is exactly 1/6 past 5. 1/6 past the whole number 5. So you've got 5 wholes plus a little more. This is the point of this video where we explore converting or rewriting, re-expressing a so-called improper fraction as a whole number or a mixed number. So let's get started looking at it formally. In the first video, I believe we only looked at a halves number line and a thirds number line. So I reminded myself, I wrote myself a little note. In this video, let's start with a fourths number line, and maybe the next one we'll do fifths, and then maybe sixths. And I wrote 8/4 up here to remind me. I suggested earlier that fraction 8/4 is the same as the whole number 2. So I've indicated that up here. And what I've done with this number line that was up there before, going from 0 to 4, is I divided each unit, the distance between each whole number, 0 and 1, 1 and 2, 2 and 3, and so on, into 4 equally sized pieces. I eyeballed that to save time, and I hope it looks pretty good to you, let's just recall what that means. Starting at 0 and taking jumps or steps, how many equally sized steps do we have to take going from 0 to 1? And in this case, it's 4. Now, I only put 3 points between the 0 and the 1. A point here, here, and here. But those 3 points created 4 spaces or jumps between the 0 and the 1. Sometimes we like to thicken in certain line segments. So there's 1/4, and then another 4th here, exactly the same length, and then another 4th here, and then another 4th like that. So there are 4 of those 4ths between 0 and 1, and it'll always work that way on a 17ths number line. Imagine creating a 17ths number line, dividing the distance between 0 and 1 into 17 equally sized pieces or jumps. So when you get to the end of that 17th piece or jump, you're going to be right at 1, because that's how a 17th number line works, how it's created. Let's start counting these 4ths now. The first 4th to the right of 0 is, not surprisingly, 1/4. The second 4th to the right of 0 is 2/4, and then 3/4, and crucially, the whole number 1 is 1 of the 4ths. When you're creating a fraction number line, the whole numbers are fractions as well. No matter whether it's halves, thirds, fourths, fifths, any kind of fraction, the whole numbers are examples of, they are part of that fraction number line. And the whole number 1 is 4/4. Now think about this for a second. If it takes 4/4 to go from 0 to 1, how many 4ths does it take to go from 0 to 2? Well, the distance between 1 and 2 is the same as the distance between 0 and 1. There are 4/4 between 1 and 2. And the whole number 1 is the 4th 4th. So 4 more 4ths will be 8/4, bringing you to the whole number 2. So continuing from 1, which is 4/4, let me circle the fractions that are whole numbers. I'll circle those. The next fraction after 4/4 is 5/4, 6/4, 7/4, and 8/4. As I indicated up here to remind me, the fraction 8/4 is exactly the same number as 2 because they are both this point on the number line. After 8/4 comes 9/4, 10/4, 11/4, 12/4. By the way, this 12/4 is 4/4 past the 8/4. Every time we go up by 4/4, we're going up by another 1 whole. So 12/4 is 3. After 12/4 comes 13/4, 14/4, 15/4, and 16/4. Sorry about that. Automatic lights, they turn off all by themselves, and not very good when you're recording a video. One of the most challenging things about teaching mathematics at any level, in my opinion, is the timing and the sequencing. When do you introduce something? I could not right now legitimately present you with a 2-step algebra equation that involves negative numbers. We haven't laid the foundation for that. And by the way, if that sounds intimidating, you'll be solving 2-step algebra equations that involve negative numbers in 6th grade, and at that time you will find it easy because the foundation will have been laid, and you'll be ready for it. I thought a lot in the last couple of days about, should I mention that a fraction could also be understood as a division? The reason I hesitated is that I'm not going to make a full explanation of it now. It's too early to give a full explanation, but it's certainly not too early to see a pattern here. 4/4 is 1. 8/4 is 2. 12/4 is 3. 16/4 is 4. How many fourths equal 5? Think about that. The whole number 5. It's down here somewhere. Well, we'd have to go 4 more fourths from 4. And if we go 4 more fourths from 16/4, aren't we going to be at 20/4? So 20/4 equals the whole number 5. Do you see a pattern? Do you see that if you read the fraction as a division from top to bottom, then you'll get that whole number. 4 divided by 4 is 1. 8 divided by 4 is 2. 12 divided by 4 is 3. 16 divided by 4 is 4. 20 divided by 4 is 5. It continues like that forever. A 100/4 is a whole number. Do you know what whole number 100/4 is? What's 100 divided by 4? You should know that. If you don't, learn it soon. 100 divided by 4 is 25. 100/4 is the same as the whole number 25. A fraction can be thought of and read as a division from top to bottom. It's both. This is both a fraction, 12/4, and 12 divided by 4, which of course is 3. So it's not a full explanation at this point. I will be providing that for you in the future. Let's just write this. Up until now, you've seen those two ways of writing division. And you really wouldn't have to write this way. This is typically just, this is a long division. It's sometimes called the division that we would do if we didn't know what the quotient was and we had to work it out through a series of steps. Well, this is 2, of course, and then if we go like this, we put the 2 up there, right? Well, now look what we can do. We can add that representation of 8 divided by 4. In fact, as you get older and we go further in mathematics, this is going to be the preferred way to express a division. You know, when you're in 7th, 8th grade, high school math, you don't typically see this symbol anymore. You see 8 divided by 4 written as that fraction. Where is 11/4 on the number line? Well, an obvious answer, but one that's very important to understand, is 11/4 is the 11th fourth to the right of 0. And I already counted the fourths all the way up to 16/4, or the whole number 4. 11/4 is right there. But how else can we describe its position on the number line? 11/4 is greater than 2. Here's the whole number 2 right here, the whole number 2. Here's the whole number 3. 11/4 is between 2 and 3. Well, can we pin it down more? Exactly where is it? Well, isn't it 3/4 past 2? 11/4, there's the whole number 2, which is 8/4. 9/4, 10/4, 11/4, 3/4 past 2. So 2 and 3/4. Okay? When we get to the point where I can assess you, give you a quiz and ask you, how can you rewrite 11/4 as a mixed number? Let's say you get it wrong, or you didn't know how to do it. Or maybe we're doing in-class instruction, and I want to explain to you why 11/4 is 2 and 3/4. Well, probably the best way is the number line, but we can't, as we go forward, we're going to have to be able to figure these things out without reference to the number line. We'll make very very extensive use of the number line to get the understanding, but then we have to sort of, like a little bird flying out of the nest when it gets old enough, we have to be able to do this abstractly in our minds. And here's what I frequently do to help students in that process, being able to do it without actually making a number line. Well, think of the 11/4 as 8/4 plus 3/4, right? We saw this in the first video. We saw that adding fractions with the same denominator is very easy. 8/4 plus 3/4 is 11/4. It's just movement along the number line. Well, why did I choose to think of 11/4 as 8/4 plus 3/4? Why not 10/4 plus 1/4? Or why not 9/4 plus 2/4? Well, I expressed it that way because 8/4 is 2. So this 8/4 is the whole number 2, and then we add another 3/4. Without putting the plus sign there, the plus sign is understood. So this is how we convert or rewrite or re-express the so-called improper fraction as either a whole number or a mixed number. Please commit to memory this notion that a fraction can be understood as a division, reading from top to bottom. 4 divided by 4/4. 4 divided by 4, 1. 8/4. 8 divided by 4 is 2. 12/4. 12 divided by 4 is 3. 16/4. 16 divided by 4 is 4. Math is incremental. It builds upon what comes before. If you are not really proficient with your multiplication and division facts, if you have to stop and think what 12 divided by 4 is, you're going to be at a disadvantage. So please do what's necessary to really master those multiplication and division facts, because much of middle school depends on them. Here's a whole number line from 0 to 4, and this time I have partitioned or divided each unit length into 5 equally sized pieces. The unit length is the distance between 0 and 1, the same distance between 1 and 2, and the same distance between 2 and 3, and so on. And now we have 5 equally sized pieces between each of those whole numbers. So it's a fifth number line. The denominator is 5 because of those 5 equally sized pieces. Let's count all of the fifths from 1/5 all the way up to the whole number 4. The first fifth past 0 is, not surprisingly, 1/5. And by the way, I don't know if I said this previously, if we want to, if it helps us, we can think of the whole number 0 as 0/5. 0/5 is equal to 0. The first fifth after 0 is 1/5. Then comes 2/5, 3/5, 4/5. The whole number 1 is the 5th fifth. We saw that earlier, right? I gave that as an example of an improper fraction that can be expressed as a whole number. The whole number 1 is also 5/5. After 5/5 comes 6/5, 7/5, 8/5, 9/5. And then the next fifth is the whole number 2. And notice which one it is. It's 10/5. The 10th fifth past 0 is the whole number 2. The same point on the number line. This point on the number line is the whole number 2. It's also 10/5. Now before I do it, how many fifths is the whole number 3? Every time you go up by 1 whole, you're going up by 5/5, right? An obvious definite pattern. 5/5, 10/5, the whole number 3 is 15/5. So let me put that one in there now. I'll fill the rest in later. And what comes next for the whole number 4? To go from 3 to 4, you have to go by 5 more fifths. because 5/5 is 1. The distance from 3 to 4 is 1 unit, one whole number, which is 5/5. So 5 whole fifths added to the 15/5 is 20/5. Look at those 4 fractions, those 4 improper fractions that I circled, and think of them as divisions, reading from top to bottom. 5 divided by 5 is 1. 10 divided by 5 is 2. 15 divided by 5 is 3. 20 divided by 5 is 4. Not a coincidence. It'll always work that way. A fraction can be thought of as a division. Let me fill in the rest of them. After the whole number 2, which is 10/5, comes 11/5, 12/5, 13/5, 14/5. Then the whole number 3 is 15/5. The next fifth after 3 is 16/5, 17/5, 18/5, 19/5, and then 20/5, which is exactly the same as the whole number 4. Which one should we pick this time? Well, how about the 19/5? Well, if I were to ask you, where is 19/5 on the number line? A perfectly correct answer would be, it's the 19th fifth to the right of 0, which is exactly what I did in counting 1/5, 2/5, 3/5, going all the way to 19/5. It's just counting. But I need 19/5 of a cup of flour to make this big recipe. 19/5. How much is that? The mixed number gives us a better understanding of the quantity, a better understanding of where that number is on the number line. We know it's the 19/5, but where is that? Well, it's past 3. Right? Here's the whole number 3, but it's less than 4. 19/5 is to the left of the whole number 4. So it's less than 4, but it's greater than 3. Well, how much greater than 3 is it? We're going to express its location as a sum, adding something to the 3. Now, we cannot add something to the 4 because it's less than 4. 19/5 is less than 4. So we go to the 3 and add something to it. I just want to take this opportunity to make an observation. When I'm talking to 5th graders about mixed numbers, about fractions in general, I will often say this. When people are very young, and this is probably true for all of you as well as for me, it was just longer ago for me. When people are very young, I'm not sure a developmental psychologist might be able to pin down the exact ages. Well, probably anywhere from age 3 to 4, maybe as far as 5. You ask somebody who's 3 years old but not yet 4, how old are you? And what do they usually say? You know, don't they say 3.5? Now, think about that for a minute. Let's say that the young person's 3rd birthday was 1 month ago. Just 1 month ago they turned 3. Is that person 3.5 years old? No. Let's say that young person, they're going to have their 4th birthday in a week. 1 week from now, they're going to turn 4. Are they 3.5? No. Both of those are very wrong, but to a very young person, like when you're between 3 and 4, all there is 3.5. So in a way, what we're doing is we're just expanding that understanding of the kinds of numbers that can be between 3 and 4. So we have a number, 19/5, it's between 3 and 4, but it is not 3.5. Isn't it? Well, you figure it out. It's 3 plus how many more fifths? You see, when we're converting from an improper fraction to a mixed number, this denominator is also going to appear over there. That's how it works. We're not going to express 19/5 as some fourths or some eighths. We're going to express the 19/5 as some fifths, because it's fifths. Well, how many fifths past 3 is 19 fifths? So let's go back and actually count them. Here's the whole number 3, which is 15 fifths. 1, 2, 3, 4. 19 fifths is 4 fifths past 3. It's 3 plus, you don't write a plus sign there, it's understood, 3 and 4 fifths. So 19 fifths is the 19th fifth past 0, and it is the 4th fifth past 3. Remember a moment ago I said that we can't use 4 when talking about 19 fifths because 19 fifths is less than 4. Well, is this true? What's 4 minus 1/5? This is really getting into some things we'll do later. But you should be able to tell me. When you subtract a number, you move to the left, right? So here's the whole number 4. If I'm subtracting 1/5 from 4, I have to move 1/5 back to the left. So 4 minus 1/5 is 19 fifths. 4, 3, and 4 fifths. Okay, but we're generally not going to express the 19 fifths as, well, it's 4 minus 1/5. We're going to express it as 3 and 4 fifths, the so-called mix. This is not a mixed number with a subtraction. The mixed number has an understood addition. Okay, so let me just take a breather now. Is this starting to make sense? If you're starting to think, this is pretty simple, it is. That's the message. This is extremely simple. The idea of a fraction. And now this idea of just taking this improper fraction, converting it to a mixed number, this sometimes troubles young people. But it shouldn't, because it's quite simple. And again, knowing those division facts, knowing that 5 divided by 5 is 1, 10 divided by 5, reading that fraction as a division. 10 divided by 5 is 2, 15 divided by 5 is 3, 20 divided by 5 is 4. What if your challenge was to come up with the mixed number that 19 fifths is without making a number line? Well, how do I express this? What is the greatest multiple of 5 that's less than 19? If that sounds confusing, it's just because you're not familiar with the vocabulary as much as I am, being around on this earth for so long. But how about this? You should be convinced that 19 fifths can be thought of as 15 fifths plus 4 fifths. If that's not obvious to you by now, go back to that first video that talked about the definition of fraction. And then also, we added fractions with the same denominator by simply moving along the number line. Why is 19 fifths 15 fifths plus 4 fifths? Well, if you go to 15 fifths, which is here, and then you travel to the right by 4 more fifths, you're going to be at 19 fifths. If you have 15 cookies plus 4 cookies, you have 19 cookies. If you have 15 fifths plus 4 fifths, you have 19 fifths. Now, why did I strategically choose 15 fifths plus 4 fifths? Why not, why not 17 fifths plus 2 fifths? 17 fifths plus 2 fifths is 19 fifths. But this is a whole number, 15 fifths. 15 divided by 5 is 3. So we have 3 plus the 4 fifths, or 3 and 4 fifths. I said a moment ago, what is the greatest multiple of 5 that's less than 19? It's 15. The multiples of 5, 5, 10, 15, 20. Well, 20 is too big. We only have 19 fifths. The 20 fifths is 4, which is bigger than 19 fifths. Okay? I think I'm going to leave it at that for now. 29 and a half minutes roughly. So unless I take a long time saying goodbye, it's going to be a little bit under 30 minutes. Please watch these videos for fun and entertainment as well as knowledge, understanding for understanding. And ask questions later on when we're together. Ask questions when necessary. So, coming up on 30 minutes. Maybe I'll make something else for you later this summer, or maybe not. We'll see. Bye-bye.